Alright, welcome. In this video, we're going to be talking about inverse functions. And in this class, an inverse function is something that's going to be thought of as a reverse mapping of the function. Like they say in the course description, an inverse function, denoted f to the negative 1 power, which is kind of a misnomer because it's not 1 over f, maps the output values of a function to their corresponding input values. Okay, that's going to be like that understanding is going to be important for us, and that's actually where I'm going to start. But before we even get to that, I'm going to say f inverse of k is the x value that gives f of x equals k, and in this class, that it will be unique. So in this class, what I'm going to suggest is that when you are confronted with a problem that asks you to find something like f inverse of, 7, that you immediately go to try to think, I'm going to solve the equation f of x equals 7. And then actually finding an inverse function can come from that process as well. All right, now I'm going to skip ahead in the notes a little bit and begin with kind of I think what's towards the back with this, interpreting the meaning of an inverse function. So we're going to say a group of students is selling m poinsettias to raise money for their organization. The increasing function m equals f of p gives the amount of money in dollars raised by selling p poinsettias. Okay, so m depends on p is what we're saying, right? The amount of money we get depends on how many poinsettias there are. So we're going to describe the function m inverse and its meaning in the context of the fundraiser. All right, so in this context, m is a function that takes a number of poinsettias and gives you back an amount of money raised. I'm writing on top of the text, but I think that's all right. Okay, so M inverse, okay, like we said before, M inverse will map the output values of the function to their corresponding input values. So I might say that M inverse, takes an amount of money raised. Say you need to raise some certain amount because that's your goal. And it'll tell you how many poinsettias you need to sell to reach that goal. And you could see that, in certain contexts, the function m would be useful, and in other contexts, depending on who you were, depending on your perspective, m inverse might be the more relevant function. Another would be the amount of milk produced at the Grover Dairy Farm last Wednesday is modeled by g of t, where g is the number of gallons produced at time t hours after production began for the day. Okay, so we're going to describe the function g inverse and its meaning in the context of the farm. Okay, so the function g takes nt, it's g of t, so it takes the amount of hours since opening and it gives you the number of gallons of milk produced. Okay, that seems reasonable. So g inverse is going to go in the opposite direction, and it's going to take a number of gallons of milk produced and tell you how long since the opening that would happen. Like, when do I reach, I don't know, 1,000 gallons of milk produced? So if you were like a customer or something, G inverse would represent how long you'd have to wait for a certain amount of milk to be produced for the day. And I think that it's good that we start with the meaning before we get into the X's and Y's here. Because in my opinion, too often in the K-12 math situation, like our treatment of inverse functions really like kind of loses sight of that reverse mapping property, especially when we just kind of swap x's and y's and then they lose all their meaning. I'll show you maybe a different perspective on it today. But first we need to talk about values of an inverse function. So f of 2 equals 5. What's the value of f inverse of 5? This is not a trick question. I'm reminding you that when you see this f inverse of 5, I want you to immediately go and say f of x equals 5 and get yourself a solution. Solve the equation. Well, okay, all they gave me was f of 2 equals 5. Okay, that must mean x equals 2. Now in this class, that's going to be the only solution. And there won't be any other solutions. That's why it says strictly increasing function. That would guarantee that. So what we can say is that f inverse of 5 equals 2. Okay. Now, on the graph of g of x equals the cube root of x, what's the value of g inverse of 2? On a graph, think about the nature of an inverse function. It maps an output value, okay, y equals 2, to its corresponding input value, which looks like it happens, right here. Okay, and then we track back to the x that got us there. That's x equals 8. So I'd say g inverse of 2 equals 8. Okay, but alternatively, okay, if we're going to solve for this algebraically, if we weren't given a picture of the graph, we'd say, all right, well, g of x equals 2. And we've got a formula for g of x. That's the cube root of x. And if we want to solve for x, we're going to take both sides to the third power. So that's going to be x equals 2 to the third, which is 8. Okay, so over here, g of x equals 2 gives us the solution x equals 8. That means g inverse of 2 equals 8. Okay, which is the exact same thing we saw up above. All right, now let's work an actual proper table question. So we're going to use the table of values to find the value of h inverse of 6 and h inverse of h of 2. And maybe you already know that these are supposed to come back 6 and 2. And if you do, then you really learned something in algebra 2. But I'm kind of trying to convince you of why that's true here. Just going back through the steps. So I think the first thing would be finding the value of h inverse of 6. First step on the left. So h inverse of 6, I'd recommend you just go ahead and say h of x equals 6 and solve that equation. Okay, I see h of x equaling 6 right there in that entry in the table. Backtrack it to the x that got me there, that's x equals 5. Okay, so I would say h inverse of 6 equals 5. And over here, if I want h of h inverse of 6, what I'm doing is taking h of 5. And when I do that, okay, I'm going to go find h of 5, and that's what I'm saying, all right? 5 takes me back to 6. So that's going to equal 6. And then h inverse of h of 2, that's a little bit easier, I think. H of 2, okay, we look over here, find where x is equal to 2, that's our input value, gives us h equals 8. Okay. So over here, if I'm trying to find h inverse of h of 2, I'll be taking h inverse of 8. And, okay, so that's going to be like finding where h of x equals 8. That's right here. Backtracks me to x equals 2, and so I get that equals 2, just like we'd expect. And that is, in general, like a fact you're going to need to know for AP Pre-Cal, and you can see that down below, that the composition of a function and its inverse will give x. That is, f of f inverse of x and f inverse of f of x are both going to have to equal x. Let's look at a slightly more algebraic example. So suppose f of x is e to the x and g of x is natural log of x. Find f of g of x. Okay, well, that's going to be f of x is e to the... Oh, wait, pardon me. I'm trying to find f of g of x. And so I'm going to say, well, f of x is e to the x, so wherever I see x, I'm going to replace that with g of x. And that's going to be e to the natural log x. We know that's equal to just x. We just studied that at great length in this class. Okay, and then if I take g of f of x, g of x is taking the natural log of x, so g of f of x, wherever I see x, I'm going to replace it with f of x in parentheses. I'm bad about that, but I should be doing that every time. For situations where there's like a power or something. F of x is e to the x, so I'm going to say that's natural log of e to the x, and we know that that's just x as well. Okay, so since we've shown that f of g of x and g of f of x are both equal to x, that means that f and g are inverses of each other. And that shouldn't be a huge surprise. Yeah, I think we probably found that out last year. But e to the x and natural log of x, they're each other's inverse. And you can say the same thing about 2 to the x and log base 2 of x. Or cube root and cubing. Square root and square, that's a little touchier conversation that we'll have here in a second. But first, I'm going to kind of just give you a set of steps for solving an inverse function. And I will warn you, this might be different from what you did in Algebra 2, but I am telling you, in my judgment, I really do believe that this is the best way to go as far as like understanding what's going on here, keeping yourself open to the concepts that will come up in future classes, even like really far away classes. The idea of an inverse is pretty important in mathematics. So I'm going to suggest first This is going to not really make a whole lot of sense until I go in and do it. But start off y equals f of x. You've known that for a long time. So you're given f of x, basically replace f of x with y is what I'm saying. But you know that, and I'm going to kind of make it a little catchier so we can try to remember it. Step 2, solve for x. Okay, this is what you're good at. Okay, I'm very confident in your ability to solve for x. And I think too often with the inverse functions, we lose sight of the fact that it's just really creating an equation solving machine. And I'll show you that here in a couple minutes. Okay, step 3 is going to be x equals f inverse of y. That's probably what I was just proposing earlier. That if I've got x and f takes x to y, okay, then f inverse is going to take y back to x. Okay, so f inverse is the type of function that really, in my opinion, should take in y's and give you back x's. Unfortunately, there's a lot of good math problems out there that are already written, like with f inverse of x. And yeah, I'm not a huge fan of graphing a function and its inverse on the same xy plane. I really don't think that makes a lot of sense. But that is a thing that, sometimes has to happen in certain math classes, and so we will learn how to do it all the same. And then step 4, that's where I'm going to substitute x for y. And let me just show you what I mean by that. All right, so step 1, y equals f of x. So I'm just going to replace it with y. Y equals natural log of x plus 3. Okay, and then I'm going to solve for x. That's step 2. So to get rid of that natural log, I need to take e to both sides power. So e to the y will equal e to the natural log of x plus 3, which we know is just x plus 3. Then I'm going to subtract 3 from both sides of this equation. So e to the y minus 3 equals x. And this might seem kind of trivial to you, but I'm going to rewrite this as x equals e to the y minus 3. Okay, because step 3 is x equals f inverse of y. But I'm kind of writing it with parentheses to make a point here that the y is, it's just kind of the input variable, as we see it as a reverse mapping. But if you kind of allowed yourself to, you could say, anything could be the input. It could be x or any letter. So we could say f inverse of x would equal e to the x minus 3. So on the right, I'm going to do the same thing. So I'm going to replace f of x with y. So y equals 2 to the x plus 1. I'm going to try to get that solved for x. So I'm going to get that variable down out of the exponent. That's going to require a log. I'm going to take the log of both sides, and the base is going to need to be the same as the base of the exponential. So that's going to be equal to x plus 1 over here. Now I'm going to solve for x, but I think it would be all right with you if I just said x equals log base 2 of y minus 1. Just subtract 1 from both sides. And then, step 3, I'm going to replace x with f inverse of y. That's equal to log base 2 of y, subtract 1. And then step 4, I've got f inverse. It's just an issue of renaming the independent variable, or I guess that would probably be accurate description. I don't really like talking about input and output here. I did that in class earlier today. Okay, that meant to be log base 2 of x minus 1. All right, now here's 2 more. And cube and cube root are great, because the cube root of a number is unique. So they work really well as inverse. They're full-blown inverses of each other without any sort of restrictions, fine print, or sidestepping. And so I'm going to ask you to try this on your own. I think you're ready. Go ahead and try to replace g of x with y, solve for x, and then go ahead and find g inverse. And I'm going to just bring my answers in here in a second. All right, there you go. So I really think that if we just look at this as like a solve for x type situation, that it first of all leverages what you're good at, the skills you've developed in the classes that lead up to here, and also kind of helps you preserve the understanding of what's going on here. Like especially in these second to last lines here, what these are saying is it's like an equation solving machine. Okay, f inverse of y. If you want to know what's the solution to 2x to the 3 plus 1 equals 127, okay, you would plug in 127 in there for y, right? And it would give you a formula to solve the equation. And that's really what the power of the inverse is. All right, now I'm gonna switch to a different discussion, domain arrangement inverse function. So if f of x equals x minus 3 squared plus 4, find f inverse of 13. Okay, so if you heard what I said earlier, you're like, okay, f inverse of 13. I'm going to set f of x equal to 13. So that means x minus 3 squared plus 4 needs to equal 13. Well, in that case, that would mean that x minus 3 squared would need to equal 9 if I subtracted 4 from both sides. And I kind of see this going somewhere, right? You can say, okay, well, I can take the square root of both sides. Now we need to remember, anytime we take square root of both sides of an equation, that does bring in a plus or minus. So that's going to be plus or minus 3. And then we keep solving this equation, and we get x equals 3 plus or minus 3. And, what I might say about this is that f inverse of 13 returned me two values. Gave me 3 plus 3 and 3 minus 3. And in general, it's kind of a more topological view of an inverse. That's not going to happen in this class. Okay, there's always going to be a domain restriction in the statement of the question that precludes that from happening. I'm going to show you exactly what I mean right here. So in AP Precalculus, the type of problem would come like I said, a domain restriction. So let f of x, just start this problem right on over, equal x minus 3 squared plus 4 on the end closed interval 0 to 3. Okay, so we are restricting the input values to just x equals 0 to x equals 3. So if we sketch the graph of f, we would think, like it's a parabola, right? And it opens up and it's got the vertex at 3, 4. But the fact that it's on the closed interval 0 to 3 means that we don't need to be, having the right side of it at all, and we don't need that arrow on the left. All right, so really it's going to look like that. And I think I am going to point out that the y-intercept of this thing is going to be 13 for reasons that we've seen already, and just because, if you plug in x equals 0, you're going to get y equals 13. Okay, the domain of f, they gave that to us. That's got to be 0 to 3. Okay, in the range of f, those are the actual outputs of the function, the actual y values that are achieved. So it goes from 4 to 13. Okay, now we're going to solve for f inverse. And, I know that we're going to take the square root of both sides of the equation, and there's going to be a plus minus, but we're going to be able to resolve it. Okay, so we're going to say, all right, replace f of x with y. So y equals x minus 3 squared plus 4. I'm going to subtract 4 from both sides. I'm going to take the square root of both sides. And, like always, that'll bring in the plus minus. And then I'm going to add 3. And hopefully those steps seem familiar because that's exactly what we did before when we were solving for f inverse of 13. All right, so over here, I'm thinking this is pretty good. This is, an equation that represents f inverse. If we wanted to get f inverse of x, we could do that later, but I'm really trying to, make a point here. And we're not ready to just get rid of the meaning of the variables. Okay, that plus minus, we gotta figure that out. Is it gonna be the plus or is it gonna be the minus? Just want you to think critically about this equation right here. On the domain that they gave us, they told us what x was allowed to be. X was allowed to be between 0 and 3. Right? So that means that if x is 3 plus or minus some number, it's gotta be minus. Okay? So I'm gonna say that really the formula over here, f inverse, I might start with f inverse of y, that's going to equal 3 minus this positive square root, because when we write the square root, we mean the positive square root of, of y minus 4. Okay, and then we could say f inverse of x is equal to 3 minus the square root of x minus 4. Okay? Now the domain of this function, obviously x needs to be bigger than 4. If x is not bigger than 4, then we're taking the square root of a negative number. Okay, what I'm going to point out is that the domain of this, inverse function is the type of y-coordinates that we can track back to an x. It's exactly these values right here. Okay, so I'm going to say the domain of f inverse, okay, that's going to be 4 to 13. And then the range, okay, actually write that in blue. Okay, so the range of f inverse, okay, that's going to be 0 to 3. Okay, and that's not a coincidence. And, these are the actual returned input values that we can get from the output values between 4 and 13. So, noticing, and you may have seen this last year, hopefully, that the domain of the original function is the range of the inverse, and the range of the original function is the domain of the inverse, and that's going to be true in general for functions that you can take an inverse of, as you can see right there in that AP Precalculus Essential Knowledge. All right, this first one, let's do some extra examples here. This is talking about a table. This is a multiple choice question. And we're interested in the inverse function. Okay, well, we can do that. We can make a table for the inverse function. And I'm going to say x and f inverse. Okay, very easy to make a table for an inverse function if you're given a table for the original function. Make that look a little better. We're just going to swap all the x's and y's. And in my opinion, that's really the trick to solving this problem. So, we look at it, it's like, okay, the x values are multiplying while the y values are adding. If you were paying any attention in the last unit, you saw that was a big theme for AP Precalculus, that, when we're multiplying by 3, so I'm going to do it times like that, times 3, the output values we're adding by 2, that means you're logarithmic. All right, so f inverse is logarithmic with output values increasing by 2. No, input values are, no, output values are increasing by 2 every time input values triple. I almost tricked myself on that one. Okay, there we go. So that's answer choice B. Right, next we've got a picture of a graph here, and suppose g is the inverse function for f. Okay, so what is g of 4? Well, g of 4 equals f inverse of 4. When you're tasked with finding f inverse of 4, you say f of x equals 4. Okay, on the graph, this is the graph of f. I'm saying 4 happens right there. Oh, goodness. That's not exactly it. But at a slope of 2 right here, right, okay, we need to be able to interpolate that value in there. So we're going to say that's at x equals 3.5. And I do know that for certain. G of 4 is going to equal 3.5. Okay, what is G inverse of 4? Oh, that's nice. I hadn't thought of that. G inverse of 4 is F inverse of 4. And it is, I think you've seen that reciprocal relationship at the beginning, that the inverse of the inverse is the original. So G inverse of 4 is going to equal F of 4, and that's going to equal 5. All right, if they ask you, what is the domain of G? Well, domain of G is domain of F inverse, so it's the range of F. And so the range of F, it runs from 0 to 7, and so I'm going to say 0 to 7 is the domain of G. The range of G is going to be the range of the inverse. I meant to write that was the same. Okay, so that's the domain of F, which is from 0 to 5. Okay, domain of F inverse, which is the range of F. I meant to write that in there. All right, What is the minimum value of g of x? Well, it's probably the least value on the range. Okay, the range of g is 0 to 5, so that would be, you know, would be 0. That would be the minimum value. I'm just going to leave it at that. All right, now here's one. If h of x, this is an interesting one, equals 4 to the 5 to the x, that's going to be a function that grows really fast. There might be some way you can simplify it, but I'm really not sure that there is. I haven't really thought about this all that much. Write a formula for h inverse. We're just going to solve for this one faithfully. So y equals 4 to the power of 5 to the x. Okay, so if we want to get the x down, we're going to have to get it out of the exponent of 4. So the first thing we're going to want to do is take a log with base 4 of both sides. And then if I want to get that x down, I'm going to have to take a log with base 5 of both sides. So I'm going to just say log base 5 of both sides. That's going to be not 5, that's going to be x. Get the variable down out of the exponent. So that's log base 4 of y. Okay, if I want h inverse of x, okay, h inverse of y is equal to log base 5 of log base 4 of y. Yeah, that's the right number of parentheses. So if I want to find h inverse of x, this is an option if you're working with a pencil that has an eraser, you could just do that. Now, on the right, we've got 2 times 3 to the x minus 4. I'm not sure. Okay, it looks a little easier than the other one. Okay, so y, actually, I'm going to write the other one now. Say 2 times 3 to the power of x minus 4 is equal to y. It doesn't matter. F of x equals y equals f of x, all the same. And so I'm going to divide by 2. Take the log with base 3 of both sides. And then I guess add 4. And since we can't find the log with base 3 of a half, I don't think that in this class we would be expected to take this any farther. Oh, I guess except for to say, all right, well, if f inverse of y equals 4 plus, I was talking about log properties, we could just, substitute with x and, have ourselves an inverse function right there. All right, here's another one of those with the square root and a limited domain. So the function g is defined by g of x equals the square root of 9 minus x squared for x being between -3 and 0. Write a formula for g inverse and give the domain of g inverse. Okay, well, the domain of g inverse is going to be the range of g. But 9 minus x squared from -3 to 0, that is going to be, I guess, increasing because it's going to start at 9 minus 9 and it's going to end at 9 minus 0. Or inside the square root, so I guess from 0 to 3. Yeah, I guess we're going to say probably the domain of g inverse is going to be 0 to 3, but maybe I'll just start by solving for g inverse, because I said that first. So the square root of 9 minus x squared equals y. I'm going to square both sides here. I'm going to say, all right, 9 minus x squared is going to equal y squared. And then I'm going to add an x, or no, I'm going to subtract the 9 from both sides and say negative x squared equals -9 plus y squared. Now I'm going to divide both sides of the equation by -1 to just get regular x squared, but really what that's going to do is just switch the signs of these things. Okay, and now I'm going to have x squared equals 9 minus y squared. Solve for x by taking the square root of both sides. And then we're going to have to say, all right, x equals plus or minus the square root of 9 minus y squared. And again, we're going to have to make a decision, but I really don't think these decisions should be too hard to make. And if you're confused, just take a step back and think about what they tell you in the statement of the problem. Okay, x is equal to positive or negative square root of 9 minus y squared. Okay, it told us x is right here between -3 and 0. X is a negative number. x must be the negative square root of 9 minus y squared. And I know that both of the examples I've done here have been where, we use the negative. That won't always be the case in AP Pre-Cal, but I just need you to be aware of this because this is the type of concept that definitely comes up in AP Calculus when we're solving separable differential equations. Right, so I can say, okay, f inverse of y equals the negative of 9 minus y squared. So I could change out and substitute with x and say f inverse of x. Oh, whoops, I guess I meant to say g. Make that change. That's equal to this negative square root of 9 minus x squared. And personally, I think the domain of G inverse, I think you're supposed to solve this problem. I think you're supposed to be thinking, okay, it's the range of G. I'm thinking about that. Well, okay, you don't probably know what the graph of G of X looks like, so I can't really expect that. So I'm going to have to go over here and think about, all right, domain of G inverse is the range of G. All right. G of negative 3 at the starting value is equal to the square root of 9 minus 9. Okay, and that's going to equal 0. And then G of 0 is going to equal the square root of 9 minus 0, and that's going to equal 3. Okay, so it went from 0 to 3, and if G is an invertible function that we're actually going to solve for an inverse in AP Pre-Cal, it's going to be just strictly increasing. Okay, so we're going to say from 0 to 3 is the range of G, so that's the domain of G inverse. 0 less than or equal to x less than or equal to 3. Yeah, but if you think about it, that should make sense with, if x went bigger than 3, we'd be taking the square root of a negative number. All right, now here's one more I want you to think about. So the range of f is the positive real numbers. G is given by g of x equals log base 10 of f of x. All right, so what they're saying is that you don't have to worry about, g of x being undefined because f of x is always positive. So solutions to which of the following equations are useful in solving the equation g of x equals 3? Maybe it would help if we wrote this out. G of x is log base 10 of f of x. That's equal to 3. Well, that's, that would be definitely an equation that would be useful. But all of these have f on their own. So what I need to do is get rid of that log with base 10. So I'm going to take 10 to both sides power. I'm going to say f of x equals 10 to the third. And that's equal to 1,000. Okay, so I'm going to say, okay, that's f of x equaling 1,000. That's answer choice B. And there we go. And yeah, that's all I've got on this set of notes, and so that's going to be all for this video. Thanks for watching.